So let's look at B. Okay, so here's another pulley problem. The W, the weight that's being held on that bottom pulley, is going to be found down at the bottom here where the problem statement is. It's 1.25 kips going down. And what we need to find is what is the value of P and what is the reaction at the ceiling. So in this case, we have P coming down. Now, it would be going straight down here, okay? And then we would have the reaction at the ceiling. We'll call that R, or what are the two values that we need to solve for. So starting with P, let's look at P first. So looking at P is going to be a strand that goes all the way down, and you're going to notice that it actually is the strand on the right-hand side here of the pulley that's holding onto that weight, right? So when we look at the weight coming down here, we're going to show it as a vector going down. We have to look how many strands are supporting that weight. And if we can draw a line right here, just like that, do you see how there's 1, 2, 3 strands that are going to support? Okay, so to draw that free body diagram, I'm gonna go here to 6.42 part B. Okay, so we'll start with free body diagram. I'm just going to draw that horizontal line. This represents the center of the pulley. Okay, and then this will be either end. So we know that at the center of the pulley, that 1.25 weight is going down, 1.25 kips, right? So that's representing the center of the pulley here, okay? The weight going straight down. And now I want to show on either side and in the middle that I have 3 forces, 3 strands that are lifting in the opposite direction. 1, 2, and 3. Now, since my weight is on center and these are evenly distributed, these are all going to be the same value. Okay. And as we pointed out when we looked at the start of the problem, this strand on the right-hand side is the strand that is going to be our P, right? So we can say this is P. And then that means that this is P because they're all going to be the same value, equal. So does that make sense to everybody? Yeah, why that's happening? Okay, good. So now we can sum our forces in the Y direction equal to 0. We've got 3 values of P here, right? So we can say 3P, because this is like a 1P, 2P, 3P. We can add them together, they become 3P. Minus 1.25 kips is equal to 0. So solving for P, we're going to get 3P is equal to 1.25 kips. And then dividing both sides by 3, our P, it's going to be that same value as before, right? 0.417 kips. So here again, we gain a mechanical advantage of 1/3. We only have to pull with 1/3 to lift or to keep in equilibrium 1.25. Okay, so that's part of the problem. That's, if you would, part A, right? That's the first part of the problem. The second part of the problem, part B, is going to be, okay, what is the reaction in that ceiling, right? So how we have to keep this up. What do we have to plan for to keep that in equilibrium? Okay, so what is the reaction at the ceiling? So here too, we're directly connected to this pulley right here. So if we kind of go, just below it, do you see how we've got 1, 2, 3, but be careful because underneath on this support right here, do you see how there's 2 more strands? So there's actually total 1, 2, 3, 4, and they're all going to equal the value of P. You guys see that? Okay. So in this case, we're going to show our reaction going straight up. Okay. Reaction going straight up. Now the first one on the left-hand side and the right-hand side, those are gonna represent on either side of the larger pulley closest to the ceiling, okay? So I'm gonna have this one and this one, and I know this is P, and I know that's also equal to P because they're the same strand going over the top. Okay. Now, down the middle here, this is connected to this smaller pulley at the bottom that we also know each one of those strands that we're lifting, that when we looked at it from the perspective of the weight of the pulley at the bottom, they were lifting up. So that means that they're going to pull down with that same value of P. They represented these two over here, and we know that those magnitudes are P. So we're going to just show this one going down here and this one going down here, representing those two smaller pulleys. Now, even though they're in the center, it would be two of those. I like to show them because there's actually 4 strands with the amount of P in them. So this is going to be 4P, right? So sum of the forces in the Y equals 0. We know that there is a minus 4P plus R is equal to 0. Knowing that P is equal to 0.417, we're going to have minus 4 times 0.417, no, 0.471 kips, 0.417 kips, plus R is equal to 0. Move that to the other side, and my reaction at my support here check my answer. Reaction is 1.668, which is in agreement with the answer key as well. Okay. All right, any questions on that last pulley problem?